topic is genetic drift. Students often have trouble distinguishing between genetic drift and the other mechanisms of evolution. In your textbook or the OpenStax online, you should have read about the natural selection and about mutations and about gene flow and genetic drift. But I'm here to talk about genetic drift. In 2018, there was a massive eruption of Mount Kilauea. Rather surprising to most people and dear to my heart because we had just snorkeled in the bay where all the lava ran in and totally decimated that beautiful snorkeling reef. But what I wanted to mention about Mount Kilauea is that this created an environmental disruption that could have provided us with an example of genetic drift. Now, we haven't gotten research studies back from it, but genetic drift is simply it's the change so you're looking at evolution. So you're talking about the change in your allele frequency in your population. But for genetic drift, it's random chance. So whenever we talk about genetic drift, we're talking about two major categories here in AP biology. We're talking about bottleneck effect and the founder effect. So bottleneck effect is essentially when you are decreasing the amount of organisms in an area in your population. So you're decreasing your population significantly, but it's a random chance event. So they're not being decreased because of any selective pressure like natural selection would lend us to have normally think about, but they're being decreased because some random chance event. So Mount Kilauea erupts, lava runs down the side of Hawaii and into the bay, and anything in its path would be killed. And so you'd lose those organisms in your population. It wasn't because they were less fit. It wasn't because the ones that survived were better fit. It was just random chance. So now you have a decrease in the frequency of your alleles of a certain type, possibly in your population. And it's almost against the rules of natural selection. So now it could have been the weakest survived. It could have been the slowest survived. It could have been anything, but not the best fit. It didn't have to be the best fit. Now, the best fit might have survived because it's random chance. So in natural selection, we see where the best fit are the ones that survive. And they survive to go on and reproduce. And then you'll build up that best fit for that environment gene pool or alleles in your gene pool. Genetic drift is not like that. So in the bottleneck effect, you're decreasing your amount of alleles in your population, and who is left is just random chance. And then, of course, they will reproduce, and then you will see an increase in those genetics in your population, those genotypes in your population, but it might not be the best fit for that environment. It's just who survived the random event. And so that's why I say Mount Kilauea is a great example, or could provide us with a great example of genetic drift. And so when we look at natural selection, we're looking at the ones that survive are the ones that are best fit for the environment, and then they pass on their traits and build that up. So don't get the two confused. Genetic drift is not natural selection. Genetic drift is kind of almost like the opposite. It's like whoever survives, and it doesn't matter how fit they are. And the other example, so that's bottleneck effect, is basically bottlenecking your population down to a random chance. So Mount Kilauea would be a bottleneck effect if it killed a bunch of some population. The other one is founder effect. Now, a founder effect occurs when a small portion of the population leaves and goes and starts its own colony. Not because they're the same traits, not because of any sort of, like best fit for that new area, just because randomly a small facet of the population cleaved off of the large population and started a new colony. And they founded, founder's effect, a new colony. Okay, so a couple of examples of that we have. Galapagos finches they believe began with the founder's effect. So the finches came from the mainland and they flew over and were blown over in a storm, and they landed on the different islands, and the population on the island was just randomly whichever finch landed there is the one that stayed there and then had babies, and then that was the genetics in that area. Okay, of course, after the founding effect happens, natural selection kicks in and the best fit of that little population would survive. But you might have some really strange genetics in that small group. So, for example, the blue people of Kentucky. Look it up; it's a real thing. There is a genetic happening. I don't want to say disorder. I guess it might be a disorder where your skin turns blue. And not really like Smurf blue, but just like, maybe when your fingers are cold and they kind of get blue, that one. And your skin, like your face is blue. And they just happen to be that the chunk that separated from the main population in this Kentucky area and went up into the hills long, 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 long time ago, had that gene. And so they kind of intermarried because there weren't too many of them. And so there are lots of blue people came up. The old Amish have a polydactyly, a trait, one of the types of polydactyly that affect them. And so some of the old Amish populations in Pennsylvania have 6 fingers instead of 5, which is actually a dominant trait sometimes. And that's because they split from the population, stayed segregated, intermarried. And so then all the population started to have this trait that wasn't in the main population because it was a founding effect. So the ones and it was just random chance. It wasn't like they were best fit having 6 fingers in this new population. It was just the people that moved there happened to have 6 fingers, or not all of them, but just a few. And then since it was a small population and they intermarried together, then you started to see lots of polydactyly. So that's one thing you need to know about genetic drift. It really needs a small population because to see like an effect like the blue people of Kentucky or the polydactyly, you need a small population. Otherwise, all those genes would be like engulfed in a larger population, and you wouldn't see that phenotype come to the surface because the other ones would cover it up. So it needs to be a small population. 1, random chance. 2, those are absolutely not natural selection things. Natural selection usually has a large interbreeding population, and then of course, they have some selective pressure that's making them best fit. It's not just random chance. Okay. So hopefully that will help you with genetic drift a little bit. It's a little bit of a different way of thinking about evolution than natural selection, but it definitely occurs. And there's a lot of examples out there that you can look up. I hope that helps you. Have a great day, and I'll see you soon.